Limit is t goes to 3 of t squared plus t minus 12 over 1 over t minus 1 over t squared minus 6. The first thing we're going to do is plug in a 3 for all of the t's. In the numerator, that'll give us 3 squared plus 3 minus 12. In the denominator, that will give us 1 over 3 minus 1 over 3 squared minus 6. In the numerator, 3 squared is a 9, plus a 3 minus a 12. In the denominator, we'll have 1 over 3 minus 1 over 3 squared is a 9, minus a 6. In the numerator, 9 plus 3 is 12, minus 12. In the denominator, 1 over 3 minus 1 over 9 minus 6, which is also a 3. Back to the numerator, we have 12 minus 12, which is 0. The denominator is 1 over 3 minus 1 over 3, which is 0. We have the 0 over 0 indeterminate form. We will have to rework the problem. Since we have fractions within this problem, specifically in the denominator, we have that 1 over t minus 1 over t squared minus 6. We will have to use the common denominator method. We therefore need a common denominator between those two terms. T squared minus 6 doesn't factor any further, so the common denominator will need to be t times the quantity of t squared minus 6. So that's what we're going to do now, is get the common denominator between those terms. The numerator I'm not doing anything with just yet. It's not a fraction, so it's not involved in the common denominator in any way. The 1 over t I'm going to need to multiply by t squared minus 6 over t squared minus 6, form of 1. And then the 1 over t squared minus 6 I'm going to need to multiply by t over t, a form of 1. So we will have limit as t goes to 3 of t squared plus t minus 12 divided by, if we're going to multiply these fractions, I'm going to start by multiplying the numerators. The numerators you want to distribute, that 1 times t squared times a minus 6, so t squared minus 6. The denominator, we will have t times t squared minus 6, but you don't want to distribute the denominator. We're going to want to keep it factored. It's important to distribute and FOIL out numerators because they're going to combine when these fractions combine, but the denominators just stay common, so we don't need to actually FOIL or distribute or anything like that. The second fraction is going to have a 1 times t in the numerator, which is just a t, and t times t squared minus 6, the common denominator. So this now can be written as limit as t goes to infinity. Numerator, we haven't done anything with just yet. The denominator, we're going to combine the fractions by combining the numerators. We have a t squared, we have a minus 6, and we have a minus t. I'm going to write the minus t and then the minus 6 so that it's in descending order. It will just make it easier to deal with any kind of factoring we may need to do. The next step in a common denominator type of problem is to take the denominator fraction and reciprocate and multiply with the numerator. The numerator is t squared plus t minus 12. We will reciprocate the denominator, which will give us a t times t squared minus 6 over t squared minus t minus 6. The t squared plus t minus 12, you can put that over 1 if you wish to make it also appear to be a fraction. This will then become limit as t goes to 3 of t squared plus t minus 12. Since we're multiplying these, let's just keep everything factored. So I'm not going to distribute anything in. These are pretty large looking expressions right now, but we will still have 0 over 0. We haven't actually canceled the factors that are making 0 over 0 just yet, and that's part of what you would need to do on a problem like this, is find those factors that are making the 0 over 0 happen. Now, because the limit is t going to 3, I would expect a t minus 3 in the numerator and a t minus 3 in the denominator, but we won't see those till we factor. Actually, they're hidden right now. One of them will be in the denominator within that, and one of them will be in the numerator within that. So those are still making 0 over 0, and we're not going to be able to cancel until we go and factor those out to find those t minus 3s. So that's going to be our next step, is to work out the factoring of each of those trinomial quadratics. So the first one, we have a t and a t. We need two numbers to multiply to negative 12 and add to positive 1. So it sounds like plus 4 and minus 3. And we also have the t, and we have the t squared minus 6. All this is going to be over. And we're going to factor out the trinomial quadratic in the denominator. That will have a t and a t. We need two numbers to multiply to a negative 6 and add to a negative 1. So that sounds like we would want a negative 3 and a positive 2. And there's the t minus 3 in the numerator and denominator that are making 0 over 0. Those can actually cancel now. So we'll cancel those out, and at that point we should no longer have the 0 over 0. And we should be able to plug the 3 in for all remaining t's. And so now we will do that, and that's going to give us 3 plus 4 times a 3 times a 3 squared minus a 6, and then divided by a 3 plus 2. In the numerator, 3 plus 4 is a 7 times a 3, and then 3 squared is a 9 minus a 6. In the denominator, 3 plus 2 is a 5. In the numerator, we're going to have 7 times 3 times 9 minus 6, which is another 3, over a 5. 7 times 3 is 21, times another 3 is 63, and we're going to end up with a final answer of 63 over 5.